Hello everyone and welcome back. We are looking in this video at question number 22 on our grade 11 Fermat paper. If x and y are real numbers, the minimum possible value of the expression, x plus 3 squared plus 2y minus 2 squared plus 4x minus 7 squared plus y plus 4 squared is. Alright, so let's copy down this expression. X plus 3 squared was 2y minus 2 squared. I think it was a plus y plus 4 squared at the end. These are all being added together, right? Yes, everything's being added. And then 4x minus 7 squared. Alright, so first thing that draws my attention, the x's are sort of self-contained and the y's are self-contained. There's no xy terms together or anything like that. So the choice of x is irrelevant, is independent of the choice of y. So if I can minimize this part of the expression with a choice of x, and then this part of an expression with a choice of y, we should have the minimum expression overall. So we could just look at the x's and y's separately. So if I just look at this, so what do we got here? X plus 3 squared, 4x minus 7 squared. So this is the sum of two quadratics, or two parabolas. Now, square terms can at smallest be 0. Every square is non-negative. But, you know, if I let x be negative 3 to make this as small as possible, then that could make this flare up a little bit. The 4 here makes me feel like we should pay more attention to this part here. But what we can actually do instead is expand this out. We'll just get a single quadratic, and then we could... Because this is just a parabola, so if we just find the minimum value of that parabola, we'll be fine. And up here we've got a parabola in y as well. So 6x plus 9, 4x squared minus 56, 4 times 14, yep. X plus 49 times 4 is 196. Alright, and then we'll get 5x squared minus 50x plus, what have we got? 205. So I can definitely pull out a factor of 5 here. X squared minus 10x plus 41. And I suppose I could complete this, yeah, because we're trying to find the minimum value of parabola, so we should put it in vertex form. X squared minus 10x, so we'll need to pull out a 25. So we break up the 41 into a 25 plus 16. Bring the 16 outside by multiplying by 5. And this will be 5x minus 5 squared plus 80. And this is minimized when x is equal to 5, and the minimum value is 80. So the stuff just involving x at smallest could be 80. Now if we do the same thing to the y's, so 2y minus 2 squared, and put that into vertex form, we'll find out where that minimum is. Okay. This wouldn't work if we had any cubic terms in x or higher running around. But this does work because everything's nice and quadratic or linear, and adding them up doesn't change that. 2y squared minus 8y plus 8 plus y squared plus 8y. Really? 8y? Yeah, 8y. Plus 16. So that'll be 3y squared, no y's, plus 24. And that's already in vertex form, so it's minimized when y is 0. and the minimum value is 24. So because the x's and y's are independent, again, this would be different if the x's somehow affected the y's, but our minimum value should be 80 plus 24, which is 114. So that should be the minimum value overall. Is that one of our answers? No, I don't see 114 anywhere here, so... Oh, it's 104. 20 plus 80 is 100, so 104, there we go. And 104 was, I think it was at the end? Yeah, E. So the answer to question 22 is E, 104. Just a tiny little mental arithmetic mistake at the end there. All right. So, there we go. Up next, we're going to have question number 23. I will see you for that in the following video. Take care.